Everyone, this is Rome, and today this video is about the application of virtual oscillator control in PV system. This is a kind of new strategy in the field of renewable energy and it's related to the solar power. Before we talk about this new strategy, let's first have some background information about the PV system and the solar inverter. So what is the PV system? It is basically using the solar panels to gather the energy from sunlight and then use the solar inverter to convert the energy into electricity. There are two of the most important parts are the solar inverter and the solar array. For the solar inverter, it is highly related to the stability issue of this PV system. As we talked before, the solar inverter converts the DC current generated from the sunlight into the AC current for customers. And in order for it to work smoothly and safely, a protection mechanism named anti-islanding is applied to the solar inverter. So with this protection mechanism, the solar inverter will automatically shut down itself if it detects there is no input power from the power grid. However, sometimes this kind of protection mechanism also causes some unnecessary disconnection from the power grid and therefore cause the problems for the stability. This is mainly because the traditional solar inverter consists of the passive components and therefore highly depends on the input frequency from the power grid. And for the solar power, which is kind of the renewable energy, unlike the traditional electric power generated from the power plant that have the constant frequencies. The solar power has unconstant frequencies, so it is more challenging for it to detect if it's just a short time voltage sink or it is a long-term zero power from the power grid. Another problem with the traditional PV system is that it applies the droop control strategy, which corresponds to the slow dynamic response time. And it also requires the quasi-stationary initial state. Therefore, to improve the stability of the PV system, a smarter inverter with VOC system is proposed. So it is called the virtual oscillator because it is not a real oscillator. It is a kind of oscillator that programmed onto the traditional solar inverter, and therefore it can mimic the behavior of the nonlinear oscillator and becomes a self-regulated control mechanism. So in the following slides, we're using the situation of islanded three-phase microgrid as an example to introduce it. Oh my God. What's the components for VOC system? It is basically very similar to a traditional oscillator. It has a LC tank, damping resistor, and it is very essential to point out that it's a synchronization condition does depend on the current gain and voltage gain of the system of the coupled inverter instead of the load impedance. And there are two kinds of algorithms for controlling VOC. One is the dynamic load sharing. It can lead to faster job response time, and it can switch between periodic and the instantaneous load balancing policies with ease. It also improves the performance when the system is heavily loaded and the load is unevenly distributed. Another kind of algorithm is called the MPPT, the maximum power point tracking, and it is utilized with the oscillator-based controller to increase the power delivered by the PV interfaced inverters. Uh, for the for the real VOC system, both strategies are used, and there's kind of compromise. So we also summarize some of the main difference between the VOC strategy and the passive inverter. So it is very important to mention that the VOC strategy stabilize the system in the time domain instead of the phasor domain, and it can stabilize arbitrary initial condition with a higher stability and faster response time, so that the system can respond to the change in the input power immediately and spontaneously. So therefore, it becomes a self-regulated inverter, and um, oh, okay. So there is also kind of limitation for this VOC system. That is, the VOC strategy is designed for isolated microgrid which works independently. Therefore, its functionality on utility scale power grid is not tested yet. So it is very essential to emphasize the difference between the microgrid and the utility scale grid. This is because sometimes the behavior of the inverter can be very different in these two kind of scales. So this is just a very general introduction to this new strategy, and it will highly help the stability of the PV system and the power grid. So here are the reference. Thank you so much.